The next work is going to be presented by Muhammed Uçar. He's a research assistant in Necmettin Erbakan University, Civil Engineering Faculty of Hydraulic Division. He graduated from Istanbul Technical University in 2014, then started his career as a site planning engineer and continued as a proposal engineer. He is now starting his PhD at the Middle East Technical University with Associated Professor Elif Oğuz. So he'll be giving us his presentation. Thank you, Mohammed, for being here. It's all yours from here.
Thanks, Mr. Emre, Uzunoğlu, and I'm immediately starting my presentation. Hello and welcome to the presentation. My presentation is titled as Comparison and Evaluation of Open Source Panel Method Codes Against Validated Data. And the validated data is obtained from VAMIT code, which is the most frequently and widely used code among the panel method codes, which is a commercial code. And we will discuss about the open source codes, NEMO and HAMS. NEMO is the first open source code which released, and HAMS is a recently released open source code. So our main motivation was to offer an alternative to the VAMIT as open source codes, the free alternatives. And our main goal was to compare if the open source codes can be used for floating wind turbines. These two structures were being used for the comparison. One of them is OC3 high spar, and the other is the OC4 semi-submersible. General features are same, almost same. You may say similar, just the platforms are different. And let's talk about mesh study. First of all, we are discretizing the geometry and defining it to the codes with beginning with a coarse mesh. This is the M1 type mesh for OC4, and we are making finer and finer the discretization and having this M4 mesh. And you may say that the volumetric representation is important here because of the calculation steps, especially for radiation damping, we may say. And for the M1 meshes, only the 90% of the volume is represented, while in the M4 mesh, beyond the 99% is achieved, which was the goal. So by getting better meshes, we are having increased number of panels, and we see that the 99% of volumetric representation is achieved by more than 1,000 panels, number of panels. So we may offer 1,500 to be a good goal to do that. And for the precision, not the accuracy, but the precision, we may talk about the self accuracy, the self precision. We may use this calculation, this simple calculation, to normalize with M4 mesh. By doing that, I have some numbers here that I'll introduce you. For NEMO, what will I say is, for the coarsest meshes, as you can see for NEMO, it's better in convergence than HAMS, because the HAMS is giving coarser and rough expectation estimation for the initial coarse mesh. But for the finer and finer meshes, the precision is same with NEMO and adequate for these numbers. So this is an example of the calculation. As you can see, all the numbers are in the graph is almost overlapped. The small differences are not observable, but I have calculated it with normalized root mean squared error values that I will introduce you. So our general results were overlapped, we may say that. And for both of the codes, for NIMO and for HAMS, for both of the structures, OC3-SPAR and for OC4 semi-submersible, the results for added mass, radiation damping, and excitation force was overall good, we may say. But let's look at deeper and talk about the axis-based comparison. I'll talk about the hue, but in general, what you see is the full of greens in the page because the normalized mean squared error was the benchmark for that, and under 5% of the difference is acceptable. I have I have accepted, but the pitch results of NIMO was insufficient. I will introduce you, I'll show you, like in this graph, this is OC4, this is for OC4, the more complex structure, and then high SPAR. For this excitation force graph, as you can see, the numbers are distant from each other. This is irrelevant, and this is unacceptable. So the NIMO users should be aware of them, of this problem for pitch axis. Even for response amplitude operator, the real motion actually is affected from the miscalculation of the pitch. Again, the miscalculation is not a general problem. Actually, it's because of, most probably, because of the miscalculation of the x distance. The origin of pitch in NIMO is different than HAMS and WAMIT, so that's why the problem. But the lack of documentation is leading this. So this is a negative part for NIMO users. It should be aware of. And this is the representation of response amplitude operator in this pitch axis for OC4. As you can see, the result is irrelevant, unacceptable. So this is not a good solution. Let's talk about the radiation damping in hue axis. In here, the benchmark, the 5% of the difference, as I said, normalized root mean squared error was not achieved, but it was unacceptable. More than 5%, but less than 15%. For the response amplitude operator, however, the real response was not affected from the radiation damping that much. So the contribution of added mass and excitation force was good, and the response amplitude operator, the mesh, the motion response was not affected by that. So as you can see, the result is here. The behavior is reflected. Both of the open source codes achieved the goal, we may say. So as a conclusion, I have one bad news and two good news. Because of the lack of documentation, pitch problem is arised for NIMO, and we could not solve the problem because the lack of documentation. And as a good news, the small differences are not affecting response amplitude operator. So the real response is not affected by the small differences in any axis. So the motion is estimated well. So, but it should also be checked under coupled loads. I mean, the aerodynamic, hydrodynamic, servodynamic codes, maybe in fast. It should be checked under coupled loads. And as finally, I may say that the open source codes can be used contribution for your attendance.
Okay, thank you, Mohammed. Quite interesting. It's quite good to see that there are open source alternatives now to panel codes that used to be quite expensive for researchers to reach and use and wasn't available at all universities. So I would like to leave the rest of this part to my co-chair, Elif Oğuz, to introduce the remaining works and herself.